Hello, very good evening, guys. Welcome to Resultant. Very good evening, all of you. I hope everyone is good, fine. Good evening, good evening. So let's begin today's session. Fine. So yesterday we had a good evening, Srishti. Good evening. We had a discussion on the subject of heat transfer. So today we'll be talking about the next subject, that is industrial engineering, a very scoring, a numerical oriented subject, and hope so you have revised that. Because yesterday only I informed that today we'll be taking questions from industrial engineering, so it will be easy for you, the questions. Okay. Yes, good evening, very good evening. Okay, shall we begin? Before starting, yes, Shravan, good evening. Before starting, please do let me know my audio and video all good, all perfect. Okay, so let's begin the session. We'll be taking questions from all the topics. We won't be skipping out any topic for GATE. Definitely, because industrial engineering is a very scoring subject, because it's all about numerical and they won't be asking any theory from this particular subject. Yes, Shubhra, I forgot that just now. I remember that I have to share. So I'll collectively share the PDF of industrial and HMT collectively. Okay. And tomorrow we'll be having session on mechanics, right? Tomorrow we'll be having engineering mechanics. So in one stretch we'll be able to complete everything. Good evening, Sayyed. Good evening. Very good evening. Let's begin. So once again, I welcome you on Resultant, and let's begin today's session with uh, different questions, gate level, more than gate level. Just like yesterday, we had questions more than that of gate level. Similarly, today also, we have taken some questions slightly more than that of gate level, so that you are able to solve all variety of questions. Okay, I'll tell Vikas sir also to share that on my Telegram channel. So no worries. After the session, I'll okay. Chalo, I think your SOM fluid SOM production one. I think SOM fluid production one in HMT and today industry. So I think these subjects is done, right? Apart from this, tomorrow we'll be having this engine mechanics will be happening tomorrow. So there's some changes in the schedule. Just now I was not available on 26, so tomorrow I'll be taking this mechanics. Okay. It was supposed to be taken on Sunday, that is 26, but I've preponed the session, so we'll be having accordingly. We'll be having this one. Okay. Chaliye. So there's a rank up course for last minute practice session. You can definitely go with this, but I think you are sufficiently prepared for GATE 2020. Okay, but if you want, if you're planning for 26, and if you want to have a practice course, definitely this rank up course, only numerical oriented course for all the students which are looking for some new kind of question. Okay, chalo, next question. First question on the screen, not next question. So Dheeraj sir, me, Chandra sir, Vikas sir, Sonu sir, all the faculties are there with our result team. So let's begin with the first question on the screen. Okay. A shopkeeper has uniform demand of an item, rate of 60 items per month. So monthly demand is given 60 items per month, and he buys a supplier at a cost of rupees 8 per item. So let me write the given data. Demand rate given as 3 units per month. The unit price is given as rupees 8 per unit. Ordering cost is rupees 12 per order. Next, holding cost is 15% of the cost price. Okay, the supplier offers a discount of 5% on the purchase of more than 2000. Okay, let's do one thing. Let's calculate the EOQ. Annual demand will be a month, that means 60 into 12 units per year. Okay, that is 720. 720 units per year is an annual demand. CO is there. CH will be 15% of C, right? and they're giving 5% discount if you are purchasing more than 200. So let us quickly calculate EOQ, Q star. Yes, I want you guys to solve it. Is a question from the discount model. Subrato Syed, Sisti, today industrial requires practice, it requires calculation. So make sure you are taking a rough page, doing the calculation along with me for this particular subject. Quickly, Q star, let us calculate Q star. 2DCO by CH root of this. So 2 into annual demand is somewhere around 720. Ordering cost is 12. Holding cost is 15%, 0.15 in root of this. Tell me what's the value of Q star you're getting. What's the value of Q star you're getting? 2 into 720. 120. Please check. Are we getting exactly 120? 144 4 times 0. Yes. Please check. Okay. So once we get this one, let's calculate the total cost uh, at EOQ. That is root of 2D COCH plus annual demand into C. So this will be 2 into 720 into CO is 12, CH is 0.158, root of this plus annual demand is 720, unit price is so total. This is at EOQ. At economic order quantity, we are getting this price somewhere around 5 into. Yes, what's the value? You'll be getting a perfect square. You'll be getting rupees 5,904 rupees. Now, whenever you're getting discount model, you should not be coming to this. They're saying that if you're having this at 200 units, what is the saving? Take the advantage of the discount. So basically, if you are ordering exactly 200 units, then you are having a discount of 5% on cost. Okay, on the cost price. So what is the new holding cost? That will be equal to we can say new holding this one cost price will be new cost price. Let us denote it as C dash. That is 5% discount on 8 rupees. So we are getting 8 into 5 by 100. We are getting 8 minus 8 into 5 by 100. Basically, we will be getting 8 into 0.95. Very good. 8 into 0.95, that is 7.6. So the new unit price, because they are giving you a discount of this one, so we'll be getting a new unit price of 7.6. Now let us calculate a total cost at Q equal to 200 units. Now in this case, whenever we are calculating at any lot size, we have to use a general formulation, that is purchase cost plus ordering cost plus the holding cost. Okay. Annual demand is 720, unit price is 7.6 plus 720 by 200 into cost. Ordering cost is how much? 12 plus 200 by 2 into CHS 0.15 of 0.15 into. Let's calculate and tell me what's the value, final value. 0.15 into 6 divided by, you'll be getting 5629.2 rupees. Okay. So they're asking you what is the saving that a shopkeeper is doing. So saving will be somewhere around, saving will be 5904 minus 5629.2. What is the saving that we are having? Please, how much? Subtract this. 274.8 is approximately 274 option B. This is the maximum difficulty that you can get from the discount model is this one. Maximum difficulty that you can get is this one. Okay. Once they have asked question from discount model, so that is the reason we have taken one question for this. Clear? Yes, yes, perfect. Srishti, correct. Subrato, Syed, Shravant, done. Option B, 274.80, the exact correct answer. Okay. Can we now go to the next one? Next question. Please have a look. If you're having any doubt, clarify this. Fine. So next question on the screen. Try this one. Very frequently asked question. It's a question from LPP, linear programming problem. That too graphical approach. This is a question from, I'll write the topic also so that you can able to visualize. They have given the objective function. This is the objective function, maximize 1.5x plus y. Subjected to two constraints is being given. Let's write in the intercept format, x by 6 plus y by 9 less than equal to 1. This is x less than equal to 5. Third one is y less than equal to 6. Let me draw the diagram over here only. X coordinate, this is y coordinate. So 5, 6, so this is 9 less than equal to means towards the origin. This is constraint number 1. Second constraint will be x less than equal to 5. So this is 5. And third constraint is x less than equal to. Okay. So we are getting this as the shaded or the feasible region. This is the feasible region that we are getting. We take the corner points A, B, D, right? So tell me what is the answer? A point is not required. Multiple solution. Very good. Now, after reaching to this point, after reaching, you don't have to check also. See, what you have to do is whenever we are having this kind of question, always check one thing. If I try to see this particular thing, or if I try to divide this equation by 2, we'll be getting this equation can be written as 1.5x plus y less than equal to 9. We can write it like this. And if you see, the slope of these two slopes are exactly same. The maximization or the objective function and the constraint is having same slope, and that too it is also a not a redundant constraint, so we can directly go with the option D as a correct answer. Okay. Whenever, remember one thing, if the objective function and constraint is having same slope, okay, is having same slope, that means LHS will be exactly same, and that too it should be a non redundant constraint. Okay, then we can get to conclusion that it is having multiple optimal solution. Okay, fine. It's a way to answer through this question. Don't need to get the coordinates and check, but definitely we'll be solving this right now in the linear way also. If I take the coordinates of point B coordinate is 5 comma 0, C coordinate is, now C is this point, at C point x equal to 5, so we can use 3x plus 2y is equal to 18. If I take x equal to 5, so y is equal to how much? Will be 15, 1.5, you can say 1.5 by 3x. We're getting C as 1.5 comma 1.5. Okay. If I take point D coordinate y is equal to 6, so 3x plus 2y is equal to 18. So put y equal to 6, 12, 12 6, 6 2 comma 6, and E is 0 comma 6. What is the objective function? Objective function is to maximize 1.5x plus y. Let us place it, we'll be getting 7.5. In this case, we'll be getting, you just have to place the equations value over here. We'll be getting 7.5 plus 1.5, that is 8, 9. This will be 3 plus 6, 9. This will be simply, we're getting multiple optimal. Okay, this is a multiple optimal solution. So this is one more way, but I will recommend you in the examination, because time is also very important. When I'm getting a question from linear LPP, that to graphical, just check whether the slope of constraint and the objective function is same, because we can rewrite this equation as 1.5x plus y is equal to or less than equal to 9, and objective function is 1.5x plus y. This is the z max. If you try to see, both are having the same slope, and that too, this constraint is a non-redundant constraint. It is participating to get the feasible region. Okay, so we can get to the conclusion option D is the correct answer. Next question on the screen. Okay, a manufacturer makes two products A and B. Total production cannot be more than 20. Raw material used to produce 1 unit of A is 1 kg. To produce 1 unit of B is 3 kg. Total available raw materials is 45 kg. If the profit of A and B, this is again a question from LPP. But here they are not given the equation. You have to frame the equation. Okay, here they have not given the equations. You have to frame it. Quickly solve this question. See, A, if I take A as x, if I take A as x, B as y. Okay, taking A as x and B as y. So this total is A raw material is, this is raw material, right? Raw, for A we are having 1 kg, for B we are having 3 kg, and what is our total raw material? Total raw material must be less than 45 kg. Okay. Next is the total production cannot be more than 20. That means production cannot be more than 20. There is 1:1, 20. Profit is for A 5. So first of all, let us write the objective function. Z max, because profit means you have to maximize. Z max is equal to 5x plus 10y. First constraint will be x plus 3y less than equal to 45. Second constraint is x plus y less than equal to 20. Solve it. I've just written the entire question in form of this. Now we can easily solve this question. Let me write in the intersect format. We'll be getting x by 45 plus y by 15 less than equal to 1. Very good, Sayyid. So answer is option B. Okay, very good. Can be written as x by 20 plus y by 20 less than equal to 1. Draw the graph. y x. First constraint is 45 and 50. 40, 15 less than equal to 1 means towards the origin. Second is 20 comma 20, 20 and 20. We're having different points we are getting over here. These are the points. Take this as point A, this as B, and as C. There are 3 points. A is having a coordinate of, right, A is having a coordinate of 20 comma 0. C is having a coordinate of 0 comma 15. How to calculate B? Just solve this. X plus 3y equal to 45. X plus y equal to 20. Subtract these two. 2y is equal to 25. Y is equal to 12.5. Y equal to 12.5. X will be equal to, evening, you'll be getting 20 minus this will be 7. So we got B coordinate as 7.5 comma 12.5. Okay, and what is the maximization? Z max is equal to 5x plus 10y. Solve it. ZA is somewhere around 100. ZB calculate. ZC is somewhere around 150. ZB calculate. 5 into 7.5 plus 10 into 12. But definitely this might be the answer. 162.5. 162.5. This is the maximum value. So answer is 162.5. Option B is, option B, 162.5 is the correct. Okay, remember one thing, either they will give you a question based on directly the equation, they'll be giving you equation, you have to plot the graph, or they won't be giving you equation, you have to create the equation, then get the answer. Okay, yes, correct, 162.5 is the correct answer. Okay, done. Next question. Today there's a possibility I'll give you some question for practice also, home practice, if you're left out with the question. Okay, so this is a question from PERT and CPM. PERT. Okay, so we have to calculate total float of activity C and G. Activity C and G. So for that you have to draw the network diagram. Let's draw the network diagram. Then we can proceed with the forward pass computation, backward pass computation. Then you calculate the total float quickly. EJ minus EI minus DIJ. Remember? Let's draw the network diagram for here only. A and B are independent, so we can start 1. This is, I won't be writing number right now. C is after A and B. So what we can do is we can draw one dummy over here. D to D. Having combination. Okay, so this is the network diagram that we are getting. Remember the number of days. A is 6, is 4, C is 3, D is 5, F is 8, G is 2. Tell me. Or what we can do is, well, let's calculate. Okay. So tell me what is the critical path? What is the critical path? Quickly. One thing. Same answer. To make that diagram quite right, correct. Same thing. Network diagram. Quickly solve it. Okay, so 0, this is 6, this is 4, 6 will be there, plus 5. 7 plus, right? Go with the backward pass computation because we need to calculate for C and G. Critical path is 24 minus this, we have, let me write 16, 9, 4, okay, minus 3. A won't be coming in the critical path. Erythro won't be coming in the critical path. Now we have to calculate the total float for C. So let me draw the C. Having a duration of 3, 6, 13, 16, 16. What is the total float formula? Total float is Ej minus Ei minus Tij. So this is Ej. This is Ei. Tij. So we'll be getting total float for activity C will be minus 6, getting 7. Okay, total float for C is 7. So we get option C. And for activity G, let me draw activity G also. Activity G is where? Okay. Activity G is 2. 9, 9, 24, 20. Okay. So we will be getting total float for activity that will equal to 24 minus 9 minus 2. That is okay. Option A is correct. Why 0? No, won't be getting 0. Activity G is not critical. Critical path is which one? Critical path will be B, D, P, D. Okay. P, D, E, F will be the critical path, and we are getting option A as the correct answer. Right? Fine. Understood. Option A is the correct answer. Done. Correct. Option A is the final correct. So see, remember one thing, if you are having any activity, this is I, E, J, L, I, L, J activity, this is duration. We can write total float is, oh, 1 second, they're asking total float, right? Total free float. Luckily we got the same. Okay, they're asking total float, right? Calculated the free float. Total float formulation is, what's the total float formulation? Your Lj minus Ei minus Tij, right? So Lj is how much? 16 minus 6, 16 minus 6 minus C, we got the same thing. Yes, yes, right. I thought they're asking free float. Okay, free float is Ej minus Ei minus, independent float is Ej minus Li minus. Okay, so they have asked total float, we will be using this formulation. Either way, we'll be getting option A only. Luckily, we got the same value, right? But the correct formulation is Lj minus Ei. Correct, correct. I thought they are asking free float, but they were asking total float. Okay, done. Next question. Okay, let's go with the next question from again from PERT and CPM. They are giving that determine the 95% confidence limit of a project completion for the given network and corresponding table. 95% Z value they are given directly is for 95%, Z value is 1.96. Expected time varies variance. Okay, so they're asking you what is the value of schedule time. Okay, they're asking you the TS value. Now, what is the formulation? We know that Z is equal to TS minus TE by the standard deviation of the critical path. Right? Can you tell me what would be the critical path? You are having the network diagram on the screen. Let me write the duration. This is 2, this is 3, 5, this is 9, this 5, 5. Quickly tell me what is the critical path. I hope you are able to see the network diagram. What is the critical path? So 0, 2, 3, 2 plus 5 is 7, 3 plus 9 is 12. So we'll be writing 12 over here. 12 plus 5 is 17. 12 plus 5 is 17. 17 plus 2 is. So the critical path will be getting somewhere like this. This will be the critical path. Dummy 1 and okay. We'll be getting B, D, F, G. 1, 3, 4, 5, 6, 7. Critical path will be 1 or B, D. Okay. So we have to only calculate the variance of this, whose variance is also given, standard deviation also given. B, D. How to calculate standard deviation of the critical path? Standard deviation of the critical path we can simply calculate by taking root of the summation of the variance of the critical path. Very good. So root of p value variance is 1 by 9. 1 by 9 plus 1 by 9 plus 1 plus 1 by 9. Okay, so we'll be getting 3 by 9 plus 1 root of this. So this will be 1 by 3, that is 4 by 3, that is 2 by root 3. Okay, so we got standard deviation is 2 by root 3. Z value is given somewhere around 1.96. So we can write 1.96 equal to TS minus TE value is 19. This is the value of capital TE. 19 divided by, solve it and tell me what value of TS you are getting. What is the value of TS you are getting? Quickly. What is the value of TS you are getting? Same thing, if you are taking the square and root, that is standard deviation. Basically the same. If you want to take square, you have to take the square of these set of values. That is 1 by 3. Okay, 1 by 3, then 1 by 3, then 1, then 1 by 3. There will be getting the same thing. Okay, Arithro, clear? So we'll be getting 21.26. Very good. 21.26 days. So that is option B. I think maximum getting 20. Option B as a correct answer. Till now, almost every question was option B only. Correct. Clear? Okay, next question. Ola electric vehicles two-wheeler forecasted that 1200 units needed for June 2021, but the demand was 1350. While for July, the demand was this one, and forecast for the August will be. Okay, very easy question. Try this. A question from forecasting. Question from forecasting model. F1 is 1200. D1 is 1350. For the second one, demand was 1429. They are asking the forecast for the third month. This was June. This is July, August. Exponential smoothing method quickly. Use exponential smoothing method. Very good, Srishti. Correct. Use exponential smoothing method quickly. And one for June was quickly. Option D. Now, if I want to calculate forecast for the month of August, you will be getting forecast for the month of, what is the formulation? F2 is equal to F1 plus alpha D1 minus F1. Yes, right. Now, if I want to calculate for August, I need to have for July minus alpha, sorry, plus alpha into demand of July minus forecast of July, but we don't know the forecast of July. Then what you have to do? We have to go with the forecast of July, that is equal to forecast of June plus alpha demand of June minus forecast of June. Forecast of June is how much? 1200 plus alpha is given 0.5. Demand of June is 1350 minus 1200. So this will give you the forecast for the month of June. Tell me the value of this. Then we can use forecast for the month of August. That is forecast for the month of July plus alpha demand of July minus forecast of June. Okay. Quickly. 1275. So this is 125 plus 5 into demand of July is how much? 14142. Answer is 1352. Okay, 1352. Any option? 1352. Option B. Option B is the correct answer. 1352. Option B, the final correct. All right, done. Clear? Option B is the correct answer. Chalo. Next question. Next question. Done. Okay. Next problem. This is a question from Queen modeling. Queen model. Okay. Let's try. A uh, customer arrive at a self-service store according to Poisson's distribution with a mean of 10 minutes, and service time is arrival inter-arrival time is given as 10 minutes. So what is the arrival rate? Arrival rate will be 1 upon 10, but you have to convert always in hours. Okay, so you'll be getting 6 as the value of lambda, right? Now what you have to do is they're asking service per customer is 6 minutes. That means you'll be taking 10 customer every minute, 10 customer every hour. The space of the front of the cashier can accommodate only 4 persons, including the serviced one. Other person has to wait outside the space. The time the customer is expected to wait before getting service. So waiting time in the queue that they are asking. Waiting time in the queue. So first of all, calculate the value of this one, lambda. Lambda will be equal to 6 minutes, sorry, 10 minutes is the arrival rate per customer. So in one, we can say 6 customers will arrive every hour. And if I say service rate, 6 minutes is required to serve one customer. So in 1 hour, how many customers will be served? You can say 10 customers will be served every hour. Okay. Now, right now they are saying that waiting time of the queue you need to calculate. So WQ you need to calculate. Okay. So rho value will be lambda by mu, that is 0.6. Calculate directly the answer. Calculate the value WQ. What's the value of WQ? Either you can use length of the queue and then divide by lambda. You can use that formulation. See, the formulation is either length of the queue, we can, that is length of the queue is rho square upon 1 minus rho, and WQ is LQ by lambda. Either you can use this formulation or you can use the direct formulation as waiting time in the queue is equal to lambda upon mu into mu minus lambda. Okay. Anyway, you're comfortable with this one, go with this one, or if you're comfortable with this equation, go with this equation. No problem. Tell me the answer. Just calculate. Waiting time in the queue is lambda value is 6 upon u is 10 minus 6 hours. You're getting 6 by 10 into 4 hours, but you have to calculate in minutes. So 6 into 10 into 4 into getting how? 9 minutes the final correct answer, option A. Okay, 9 minutes, option A the correct answer. 9 minutes, option A final correct. Clear? Chalo, next. Same a question from, so you're getting 6. Solve it now. 9. Everyone's getting option A, right? 9. Okay, next one. Again, a question from Queen theory. Arrival rate of a telephone call at telephone booth is according to Poisson distribution. Average time is 9 minutes between consecutive arrival. That means arrival rate will be, we can say 60 by 9 customer per hour, right? The length of the telephone call is this one. So this one will be 60 by 3 customers per hour. That is 20 customer per hour. Okay, that is 20 by 3. Now the telephone company want to install a second booth when convinced that arrival rate would have to wait at least by 4 minutes. Okay, so they are saying that the waiting time, okay, the waiting time in the queue is 4 minutes. So what should be the arrival rate at that time? Very easy. Quickly solve it. We know arrival rate. So here we can use the direct formulation. WQ is given as 4 minutes. And that is equal to same formula, lambda upon mu into mu minus lambda. Let's take it as lambda 1 because arrival rate, the new arrival rate that we have to. Okay. So now what we can do is we can place everything. Value of this is, okay, we have to calculate it minutes only. Let us calculate minutes. Everything is minutes, so 1. Okay. So we'll be having lambda 1 upon 1 by 3, 1 by 3 minus lambda 1. Solve it and what's the value of lambda 1? 4 by 1 by cross multiply and get the value. Quickly solve it. Four. Well, lambda 1 is equal to by per minute. So they're asking increase in the flow of arrival per minute. So initially we had 1 by 9, now it is being, so increase in the flow will be in flow of arrival will be equal to 1 by 4 by 21 minus 1 by 9. Tell me what's the value? Getting 5 by 5 by 63. 5 by 63, any option? Yeah, option C is correct. Okay. So these are not PYQs. I'm again repeating. These are the questions level more than that of GATE. Okay. These are the questions level more than that of GATE. 5 by 63. Perfect. Done. 5 by 63. Done. Any doubt or difficulty? Okay. Chalo, next question. Before going to the next question, the students who are planning for 25 or 26, okay, 25, 26, I hope so everyone knows about this. Let's have a quick important update. We are already gonna start the live classes for 25-26. PDF notes will be available. PYQ question bank definitely for in time will be there with you after the examination also. Okay, fine. So you can do connect with us on our resultant channel and make sure you are downloading our app so that you can enjoy the free access. There are some free questions also on our resultant app. Okay, fine. Next question. They're asking that two jobs are to be processes on two uh, machine machines, not mechanics, in sequence for minimum span time. What should be the sequence? Very easy question. I want everyone to answer this quickly. What should be the sequence for minimum? Quickly, solve it, solve it. For minimum span, that means a simple Johnson's rule. Apply Johnson's rule over here. After gate will gonna bring. Say because BHCL, the level of paper questions are not that of gate, than that of gate only. That will be having slight easy calculator. So let's see the minimum value is in machine number 2. We have to start from the end. So this is 6. Any option now. Then we're having 2 in the first machine. So we'll start with 3. Then we're having 3. Second machine, this is 1. Option D is not possible. Then we are having 4 on the both the machines. This on this will be getting 2 over here and 5 over here. We left out with so 3, 2, 4, 5 and 6. Option A. Option A is correct. Option A is a correct answer. Okay. Option A. Next question. Perfect. This kind of question has been asked in the examination. Don't worry that this kind of question, if they're asking, so you should be very lucky. You should be very happy because you won't be committing any mistake in this kind of question. Right? Okay, next one. Free float of activity 3-4. Free float of activity 3-4. Where is 3-4? This one. So let's go with forward pass and backward pass computation. 0, 2 plus 8 is 10. 2 plus 10 is 12. 10 plus 6 is 16. 2 plus 12 plus 3. Then 10 plus 3 is 13. 13 plus 2 is 12 plus you will be getting E. Okay. Then 5. Critical path, very good. No, Srishti, critical path won't be that. Draw the critical path. This is a critical path. Okay. Critical path will be 0, 1, 7. go with backward pass, this will be 12. They're asking 3, 4. 4, 12, 12, 22. 3 float formulation is K minus EI minus IJ. 16 minus 12 minus 3. Getting okay here. Done. Option A is a correct answer. Quickly have a look if you have any doubt or difficulty or any calculation that you're not able to understand. Okay. Correct, correct. Option A, 1 is the correct answer. Okay, next one. Three machine job. Okay, so they're asking the optimal sequence. Optimal sequence. There are 3 different machines on 5 different jobs are there. So how to go with this? For that we have to check one condition. Remember? For that we have to check one condition. Basically, no need even to check also because it is there. But still, if you want to check, the minimum of machine A should be more than equal to the maximum of B. Like there are 2 conditions: the minimum of greater than equal to maximum of B, or the minimum of C must be greater than equal to maximum. Any one of the question must equation must be satisfied. Minimum this 3 not possible. But here, if you see this one, this is applicable because minimum of C is 5 and maximum of this is 5. So definitely this condition is being satisfied, right? So now we can club X, can assume 2 hypothetical machines X and Y. So we are having 7, 8 plus 5 is 13, 7 plus 1 is 8, 5 plus 2 is 7, 4 plus 7 is 11, 14, 6, 8 and so now let's go with 1, 2, 4 and 5. Option A, B, C or D. But same thing, now we have converted this 3 machine into 2 machine job. The least value is 6, which is in second, and write 3 the end. Option A. Option A, no need to complete also. No need to complete also. Option A is correct because only one option is there which is having ending with 3. Option A is correct. Very good, Sayyid. Okay, but we'll complete this over here. We're having okay. So next is 7. 7 is present in almost 3. So whenever we are having equal, then we have to check the corresponding. Okay, so for that, lowest value is with this one, so we'll write with 4. Then next lowest is this one, that is 1. And next lowest is this one, that is 5. We'll have to write 2. So 4, 1, 5, 2, 3. 4, 1, 5, 2, correct answer. Okay, fine. Option A, 4, 1, 5, 2 is a correct answer. Done. Next question. Clear? If you have any doubt, please tell me, or else you can go to the next one. These questions are very easy, right? Okay, next question. 4 factories A, B, C, D, capacities are 10, 8, 5 and 6. Respectively supply sugar. Demand is 7, 12, 5. 1 ton of the sugar. Okay. They're asking you the transportation problem. This is a question from transportation. First of all, tell me, is it a balanced one or not? First of all, tell me whether this is a balanced transportation problem or not. Quickly. If you add this 10 plus 8 plus 5 plus 6. 29. To add this, this will be 12, 12, 24. So this is an unbalanced. This is an unbalanced transportation model. It's an unbalanced transportation model. So how to do the balancing? Where you need to add dummy? Can you tell me where you need to add dummy over here? In the factories, row wise or column wise? Tell me that. We need to add dummy row wise or column wise. Perfect. So what we have to do is write x, right? Have to add dummy. Complete 4, 5, 6, 1, 6, 4, 5, 4, 5, 4. Capacities are given 10, 5, 10, 12, 5. Okay. Now let's do. They're asking you only northwest corner rule. So northwest corner rule means left. Okay. Northwest corner rules mean that we have to start with the left one. One thing. Let's make boxes. Okay, so here we need to add, okay, what should be the allocation in the first one? You have to always allocate the least one, that is 7. So this is completed. This is 7, 3 left out. Okay, let me write 0 left and strike off this one. Now again this one you have to go with 3. This is 0, we are left out with 9. Strike off this one. To allocate this one, that is 8. 0, we left out with 1. The row. So again allocate this 1, 4, row, having 4, 1. Okay, we are done with the allocation. We are done with the allocation. Now we can calculate the total cost. This is northwest corner rule. Okay, northwest. So total cost will be equal to 4 into 7 plus into 3 plus 6 into 8 plus 4 into 1 plus 3 into 4 plus, tell me what is the value? What is the final expression that we are getting? 28 plus 9 plus 48, 4 plus, check what's the value? 105. Please check, are we getting 105? 105, 105 option. Okay, because they are giving you in thousands, I think. hundreds, is given in hundreds, so 1 not 5 hundreds. Okay, option A is correct, right? Option A 10500, because the cost that we are given is in hundreds. Option A 108. Please check the calculation. Is it 108 or 105? Quickly. 105, right? Correct. Done. 1 not 500, because they have given everything in hundreds, so we can go with option A. Okay, next question on the screen. So they are saying that there are 5 jobs waiting to get processed on a machine using slack time remaining, STR. What's the value of STR? Can you tell me? Slack time remaining is due date minus processing time. Okay, due date minus processing time. So first we'll calculate the value of STR. 7 minus 5 is 2. 8 minus 5 is 3. 10 minus 6 is 4. 5. Okay. Tardiness. They're asking you the tardiness. So you have to tell me the sequence. What will be the sequence? What should be the sequence? Quickly. Always go with the increasing value. So we'll start with J5. And we'll go with J1. And we'll go with J2, J3, J4. Okay, this will be the sequence that need to be followed by using STR rule. So we are getting jobs, processing time, date, job A5 1, the corresponding processing time for J5 is 5 and 7. J2 is 5 and 8. J3, J4 is 2 and 3. Okay, we can write job flow time. Then we can go with tardiness. Okay, so 0 plus 2 equal to 2. We have to first arrange in the sequence, then we have to start with the calculation. The sequence was 5 1 2 3 4. So 5 1 2 3 4. 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 6 is 18. 18 plus 2 is 20, and this is called as make span. Increasing order. Okay, increasing means lowest was 1, then this one, then this one, right? So tardiness. Now job number 5 was supposed to be completed in 3 days. We are completing 2 days, so this is not a tardy job. You have to supposed to be completed in 7 days. We are completing 7 days, not a tardy job. Supposed to be completed in 8 days. We are completing in 4 days. It is being late by 4 days. Supposed to be completed in 10 days. We are taking 18 days. 8 complete need to be completed in 7 days. We are taking 20 days, so it is nothing but 13. What is the question they're asking? What is the average tardiness? Average tardiness means total tardiness will be, add these two. 12 plus 13, that is 25. Average tardiness is total tardiness by number of jobs. So total tardiness is 25, number of jobs is 5. You're getting answer 5 on average jobs is 5 days. Option A is a correct. Option A, 5 days is the final correct answer. Done? Clear? Option A, 5 days is the final correct. Any doubt or difficulty? Easy one. The sequencing questions are very easy, right? Either they can ask, if you're having only one machine, they can ask you question from SPT rule, okay, or EDD rule, or STR rule, or critical ratio. Fine, perfect. Next. Demand is 1000 units, unit cost is 100, ordering cost is 160, inventory carrying cost is 20 per unit per year, back order cost is also given 10. So it's a shortage call. What will be the selling cost per unit for no profit, no loss? They're asking you for no profit, no loss. What should be the selling price? Interesting one. When you total. Chalo, try this. This question is a combination of shortage model with the break even point. Two concepts. Try this one. First of all, calculate Q star. Okay, first of all, calculate the Q star value. Required? Not even required. Okay, can you tell me what will be the total annual cost for shortage model? For shortage model, T star is equal to root of root of plus. So annual demand is given somewhere around 10,000, 2 into 1000. Ordering cost is 160. PH value is 20. Back order cost is 10. Annual demand is 1000 into. Okay. Can you tell me what is the value you're getting approximately? You'll be getting 10,146 point. Okay. So this is the total cost that I'll be getting at the minimum price. So can we assume that at BEP, at break even point, what is break even point? There is no profit, no loss. No profit, no loss condition, right? So can we say the total sales will be equal to the total cost? Total sale will be equal to total cost, right? And total cost is how much? 101,460.6. Total sales, we are selling how many units? We are selling 10,000 units in 1 year. So we can say small s into 10,000. Oh, not 10,000. S is coming out to be 101.46 rupees per unit. This much rupees you will be getting per unit. This is the selling price. Unit selling. So you have to sell with 101.46 means option B. This was a unique problem, which is a combination of break-even point and your shortage model. Okay, clear? Done. Okay, so there are, I think, one or two questions left out. I'm giving you these questions as an homework so that because already we have solved a question from LPP. You can try this one at your home so that you can practice. I'll share this PDF with you. Don't worry. Okay, I'll share this PDF with you, and make sure you are writing the answer in the comment section after solving this. Tell me in the comment section or in the chat box the answer for it. Okay, clear? Fine. I'm giving you two questions. This one. This is a question from PERT and CPM crashing model. Crashing model. So two questions I'm giving you as an homework. Try to solve these two questions and try to comment your answer in the comment section. Tomorrow, before starting mechanics, I'll try to take the names of the students, those who have solved it. Okay. I'll see how many students have solved these two questions before starting tomorrow's mechanics session. Right. So that's it for today. And those students, those who are planning for 26, there's a target 26 batch. We have launched all the live classes, recorded classes, study notes, PYQs, question bank, doubt session, everything is included in this particular okay. Fine, all the mechanical students, so targeting for 26 definitely. And before leaving the session, make sure you all are following us on our Instagram channel, so that any update is coming, live discussion, we can directly quickly start. Like usually what we do, we try to start the live session on our resultant Instagram, so that you can have a one-on-one. Okay, fine. So that's it for today. I hope so you all enjoyed. Let's meet tomorrow for the mechanics. Very important. Okay, tomorrow we'll be having mechanics. Tomorrow we'll be having it, that too at 8 p.m. Very important. Nowadays, if you see in the last 3-4 years, the weightage of mechanics has tremendously or drastically increased. So I hope so. And level of question also, it is being increased. So we'll be solving a good level of questions also. Okay, fine. So thank you guys, and do take care of yourself. Let's meet tomorrow 8 p.m. This certain. Fine. Any doubt, any difficulty? All clear? Please make sure you are solving these two questions. This one from LPB, right? They're asking the minimum cost. It's a minimization problem. Second one is the crashing model. They're asking the optimum cost. Okay, I've given you the cost, normal cost, cash cost, the time, and the cost value. So just use it. Okay, that's it for today. Thank you guys for joining with me. I hope so you all enjoyed attending this session. Okay, thank you. Bye bye. Good night. Take care. Stay safe and enjoy your preparations with resultant. Thank you.